excuse me, for matrix multiplication, that's the operation we haven't looked at yet. It's not the same as adding and subtracting where the number of rows and columns has to be equivalent. When you're multiplying, because it's a certain type of distribution that you're doing, the number of columns in A has to be equal to the number of rows in B. So if you look at that little excerpt or a little comment below here, it says if you have one matrix that's an M by N and another matrix that's an N by P, the reason you guys can multiply them is because the columns in the first row matches, or in the first matrix matches the rows in the second matrix. So when you guys actually multiply them, what happens is it becomes an M by P matrix because of the way we multiply and distribute our values. So we will look at an example, but that might help you as to see what you start with and what it becomes. So the columns in the first one has to match the rows in the second one. And what will happen is you'll end up with the rows from the first one and the columns of the second matrix as your dimension. So if we look at example A, if we had a 2 by 2 matrix and a 2 by 3 matrix, these two match, so that's good. Your dimensions will become, or your matrix will become, a 2 by 3. So, next example, a 3 by 3 matrix and a 2 by 2. These do not match. So this is actually not possible to multiply. And you will come across that. You wouldn't have the correct values to be able to multiply everything correctly. So if those dimensions don't match, the columns in the first times the rows in the second, you guys can't multiply them. So even if you don't find it helpful, just make sure you guys sort of highlight it and come back so you guys can find it quickly if you don't remember what needs to be what in order for you to multiply them. So, just one more time, columns for the first have to match rows for the second. Your dimensions become rows of the first, columns of the second. So let's actually do some multiplying with them. For multiplication, order does matter. The reason it matters is if it didn't matter, then we wouldn't care what the dimensions were because we could just multiply whatever. Then it wouldn't matter if the first columns matched the rows of the second, because if you switch them, then the rows of the first would match the columns of the second, and it wouldn't work. So for multiplication, it does matter. So what that means is if you're trying to multiply your first matrix times your second matrix, A times B does not equal or is not the same thing as B times A. So it's not commutative, and order does matter when multiplying matrices. I know it's never mattered before in multiplication, but it does for a matrix. So it wants us to multiply the following matrices if possible. And I think I may backtrack here and just do one at a time just to save space. So give me a second. So for number 1, we have a 2 by 3 and a 3 by 2. So our columns matches our rows, so that's good. So when we go to multiply them, what's going to happen is we're going to take this first row and multiply it by both of our columns. We're going to find the sum of each of those operations. So what that means, we'll do 3 and 1 and 0 times -1, 2, and 5. So we'll do first row times first column first. So 3 times -1. And we're going to add them all up. So 3 times -1 plus 1 times 2 plus 0 times 5. Once we add those together, that's going to be our first entry of our product matrix. Okay, well now we have to do your second row, which is 0, 3, 0. So 3 times 0 plus 1 times 3 plus 0 times 0. Once we add those up, that will be our second entry. Now we have to do our second row times both of the columns. So -1 times -1 plus 4 times 2 plus 2 times 5. And if you guys do this in your head, it's absolutely fine. I'm just going through the entire process. That'll be our third entry. And the fourth entry will be second row times second column. So -1 times 0 plus 4 times 3 plus 2 times 0. So -3 plus 2 is -1 plus 0 is -1. That's our first entry. All right, second spot, 3 times 0 is 0, plus 1 times 3 is 3, plus 0 is going to be 3. -1 times -1 is 1, plus 8 is 9, plus 10 is 19. And then your last spot, -1 times 0, so 0 plus 12 plus 0 is just 12. So that is going to be the product of those two matrices. And it did become a 2 by 2. So another good way to just sort of check and make sure that at least we know we did that part correctly. So multiply each row by each column. I always just do it one row at a time. So depending on how large your matrices are, you're just going to repeat that process. So multiply first row by all your columns, then the second row by all the columns. If you have a third row, multiply the third row by all the columns in the second matrix. And the sums of multiplying the rows and columns together will be your entry values of the new matrix. So it's sort of new to you guys, so let's look at the second one and we'll do the same process. So for number 2, we have a 3 by 2 and a 2 by 3. Columns matches rows. Good to go there. It should become a 3 by 3 matrix. So let's just get started here. And again, if you guys do it in your head, that's fine. I'm just writing every step down to start us off. So multiply your first row by all 3 columns first. So let's see here. 0 times 1 plus 2 times -2 will be our first entry. Okay, next column, 0 times -5 plus 2 times 0. Third entry, 0 times 4 plus 2 times -6. And I'm going to need bigger brackets here. Alright, let's do our second row, which is -2 and 4. So -2 times 1 plus 4 times -2. -2 times -5 plus 4 times 0. -2 times 6 plus 4 times negative 6. And our last row, 3 and 1. 3 times 1 plus 1 times negative 2. 3 times negative 5 plus 1 times 0. And our very last entry will be 3 times 4 plus 1 times negative 6. So just add all those values up, and that's going to give you your new matrix. So I'm going to take a second and pause this. So I added all of our sums up, and I got negative 4, 0, negative 12, negative 10, 10, negative 32, 1, negative 15, and 6. And it did become a 3 by 3 matrix. So I think we did okay. So again, you guys don't have to write all of those values out. It's just doing the multiplication and the addition correctly. I'm just going through the whole process with you guys. The last one on that page, number 3, we have a 2 by 2 and a 3 by 2. So the first one has 2 columns. The second matrix has 3 rows. So this one is actually not possible to multiply. So we don't have to worry about it. I'm going to do number 4 and 6 with you guys yet on this page, and I'm going to hopefully have you guys successfully complete number 5, 7, and 8 on your own. So 4 and 6, they're sort of easy, they're confusing, but if you look at them, we have for number 4, a 3 by 1 and a 1 by 3. So 2 really small matrices that are able to be multiplied together because one row or one column in the first matches one row in the second. We are able to multiply them together, but when we multiply them together, they're going to become a 3 by 3 matrix. So let's go ahead and multiply it out. So what's going to happen is we need to multiply that whole column, negative 2, negative 3, and 1, times each column in the second matrix. So what will happen is we'll get negative 2 times 1 as the first entry, negative 2 times 2, and negative 2 times 3. So if you guys are seeing that that's all this is going to be, you guys can probably figure out the rest easily, what the matrix will end up as, but I'm going to just, again, go through the whole process. So negative 3 times 1, negative 3 times 2, negative 3 times 3, and your last one, 1 times 1, 1 times 2, 1 times 3. So your matrix ends up being negative 2, negative 4, negative 6, negative 3, negative 6, negative 9, 1, 2, 3. So it's weird, or I think it's odd, because you start out with 2 small matrices, so you would sort of think, or I would think that you would end up with a small matrix, but that's not the case. You end up with a 3 by 3 matrix of the following. So let's look at number 6. Same thing again. We have a 1 by 3 and a 3 by 1. So your rows and columns do match, but you're going to end up with a 1 by 1 matrix. So let's work through this. Because we multiply the rows first row times all columns, second row times all columns. Well, we only have one row. That's 1, 2, and 3. Those are the values in that single row. So we're going to take that row and multiply it by the first column, in this case, the only column. So what's going to happen is we're going to do 1 times negative 2. Remember, we're finding the sum. Plus 2 times negative 3 plus 3 times 1. We've just multiplied the only row by the only column, so we're done. So what's the sum? Negative 2 plus negative 6 is negative 8, plus 3 is negative 5. So we do end up with a 1 by 1, and that's it. So go ahead and try 5, 7, and 8. I'm going to move down and do that sports one with you guys. You are more than welcome to try it on your own and come back and check. So it's talking about sports teams, and it gives women's teams and men's teams lists of the equipment that they're going to need for each season. And then it also tells you, okay, well, each bat costs $21, each ball costs $4, and each uniform costs $30. So use matrix multiplication to find the total cost of equipment for each team. So if we're trying, the way you find a cost of something, if you have this many and each one costs this much, you multiply the number by the price or the cost, correct? So your second matrix will be the cost of each item, while the first matrix is going to be the quantity of everything. So the first matrix is going to be the women's equipment and the men's equipment. So I'm going to do the first row as the women's equipment. So we'll do 12 for the bats, 45 for the balls, and they need 15 uniforms. The men's will be 15 bats that they need, 38 balls they need, and 17 uniforms. We'll now multiply that by how much each costs. So remember, again, we multiply the row by the columns. So if 12 is the first number in the row and that represents the bats, the first number in your column needs to represent the bat cost. So each bat costs $21. Second number in your row represents the balls. The balls cost $4. And the uniforms cost $30. So what is matrix A times matrix B? And this starts out as a 2 by 3 times a 3 by 1. So we should end up with a 2 by 1 matrix. So what is 12 times 21 plus 45 times 4 plus 15 times 30? 882. And then what is 15 times 21 plus 38 times 4 plus 17 times 30? $977. So it's going to cost the women's team $882 for their equipment. And the men's team, it will cost them $977 for equipment. So again, just acknowledging what are we trying to accomplish and how do we use matrices to accomplish that. If you guys have any questions, please make sure you're asking or coming up and getting help if you